This lab is about enzymes. Enzymes have a specific name. Usually they end with an ASE. So in this case, we're looking at shoestringase, and the enzymes are named after what they do. So in this case, we're going to be tying shoestrings and untying shoestrings, because enzymes can work both directions. They can put things together and they can take things apart. So you're going to need some kind of timer or stopwatch. And what we're going to do first is just tie our shoes. So in this case, we're just going to time how long does it take to normally tie a shoe. So we get our shoestrings like this, we get ready, and then hit start, and then just time how long does it take to normally tie a shoe. Once you get that number, what we want to do is see what would happen if we have a lot of substrate. So in this case, our shoestrings are the substrate, the molecules that are interacting with the enzyme. So what if we had 1,000 shoes to tie? So 500 pairs, but 1,000 shoes to tie. Well, we would just take our number, however many seconds it took us to tie our shoes normally, 6 seconds, 8 seconds, and times that by 1,000. But what if you had help? If you had help, if there was a higher enzyme concentration, if there were more people working, what would that do to the overall time? In part 2, we're going to look at enzymes that are denatured. So the problem here is that something like pH or salt concentration, maybe it's the temperature, has changed the nature of the enzyme. So we're going to try to tie our shoes, but this time we're going to have our fingers crossed. So you might notice that it's difficult to do that same process if the enzyme is denatured. So in this case, we're going to cross our fingers and try to tie our shoes, keeping our fingers crossed. Time, how long does that take? In part 3, we're going to try the same thing, but this time with a mutation. Mutations in DNA affect how proteins are made. And remember, enzymes are proteins. So in this case, there's something wrong with our DNA. There's a mutation which causes the enzyme to not be built correctly. So for example, lactose intolerant individuals have a mutation that does not allow them to make lactase, the enzyme, properly. So now we're going to try to tie our shoes, but this time we're not going to use our thumbs. All right, so if it helps to just maybe tape your hand so that you can't use your thumb, or if you can just do it without the tape and keep your thumbs together there, try to tie your shoes, but this time don't use your thumbs, and see how well that goes. All right, so see if you can get your shoes, and just again time it. How long does it take? That gives us an idea a little bit about how enzymes work and some of their characteristics, that enzymes are specific, that enzymes can do reactions in either direction, that enzymes don't get used up, like your hands don't get used up tying your shoes, that the concentration of the enzyme matters, that denaturing the enzyme matters, and mutations matter. So that's our Shoestringase lab.